38 convert BST to greater tree. So this BST is binary search tree, and here is the definition of a binary search tree. We should know about that for the binary search tree. If this is the root node, it is value 4, and all the nodes at the left side, so the value should always be smaller than 4, as you can see 0, 1, 2, 3, and all the node to the right side of the tree is always bigger than the root node, than 4, as you can see 5, 6, 7, 8. Yeah, and all the values of the node would meet this kind of condition traversally. Yeah, so it means for this one, this is a 0, and for the right side it is 2, and for this 3, it must be at the right side. Yeah, so this is the property of the binary search tree, and we want to calculate the we want to convert it to a greater tree. So this greater tree just means for the value, for example, this value is 7 for this node, and we're going to accumulate all the node which is bigger than 7. So this is 8, so it's going to be accumulated to 7 plus 8, it is 15, and for this node, it is 6 plus 15, it is 21, and for this node, it is 5 plus 21, it is 26. Now you know the patterns of this problem, because this is a tree traversal problem, but our traversal is not like in order traversal, post-order traversal, or pre-order traversal. This traversal is the first traverses the right node, right subtree. Yeah, so this is the right subtree, and then we're gonna traverse the root node. After that, we're gonna traverse the left subtree, because we want to meet the conditions of the accumulated values. For example, this is 7. We're gonna accumulate all the values which is bigger than 7. It must be 8. It must be at the left side. And for this 6, it must be at the left side. What about this 5? Yeah, it also must be at the left side. So it means we're gonna accumulate the left node first, and then the root node, then the right node. Yeah. Now let me just continue coding. If we know a little about the traversal problem, yeah, so for the tree traversal, we're gonna put a node inside, and then we're gonna write the traversal. So here I'm gonna write a DFS function. So if there is a node, I'm gonna run the DFS first from the right side, not dot right, and then it's gonna be from the left side. But in between, I will check the values. Yeah. So this means I gonna prepare a global variable, so self.result as 0. Yeah. So from here, I need to accumulate all the values. So self.result plus not.val. Yeah. So yeah, for here, for example, I'm gonna first check this node 8. Yeah, because it gonna for the root node, it gonna always recursively call the function to the right side and then right side until I find a root node which is 8. But at the right side there's nothing. At the left side there's also nothing. But I'm gonna take this value. So here self.result would plus equal to not.val. It would be 8. Yeah, and I need to assign this value to my current node. So not.val should be equal to self.result. And then I will return nothing because I didn't have a return, but I will start the DFS from here. Yeah, and then I will go back to this node 7. I didn't return anything, but I will accumulate the value from this 8 to this 7. And how can I do that? So now I finished the node of 8, and then I go back to 7. How can I go back to 7? So basically, so for this 7, I've already know from 8, I've already returned a value of 8. Now I'm gonna call the function from this node 7. Yeah, so from the node 7, I'm gonna call the function. So first of all, I'm gonna check the DFS not.write. So for the DFS not.write, I've already accumulated the value. So the self.result has already been 8. Yeah. Now what I gonna do? So from this is 7, so self.result should plus not.value. So here the not.value is 7. The self.result is 8. Yeah, because I've already finished the function call of DFS not.write. I just get a result of 8. Now I'm gonna execute the second line. So the self.result, this is 8 plus equal to not.val, it is 15. And then I'm gonna assign the value, assign the 15 to the not.val. So currently this not.val will be assigned to 15. And then I'm gonna execute the DFS not.left. But there's nothing at the left, so I'm going to the next DFS. So the next DFS, it will be here, and then accumulated to 21. After that, I'm going to call the left. So from the left side for this node, yeah, so for this node, if this is the DFS for this node, yeah, so the self.result is 21. I should plus equal to this not.value, so the value is 5, it is 26. And I will update the value, so not.val should equal to self.result, and this will be updated to 26. And then I go to the left, and there's nothing from the left. And all the function will be working like this. After that, I will accumulate all the values. So for each of the node, I will accumulate all the values which is bigger than the not.value. So if I accumulated everything, basically I just need to return the root. But before that, I need to run the DFS with the root. Now let me run it and submit it to check if it works. As you can see, it works. And the time complexity is just O(n) because this is a tree traversal. We just need to traverse all the nodes.